This is the first video in a series of 3 videos about cost theory. In subsequent videos, I use numbers and calculus as well. And I would encourage you to try to watch all 3 videos. And the first video, this one here, is an introduction. I put quantity on the horizontal axis and total cost on the vertical axis. I draw in the total cost curve and the total variable cost curve. Lastly, I draw in the fixed costs curve. The total cost and total variable costs are parallel to each other. Total cost is equal to total variable cost plus fixed cost. If I take fixed cost, which is that distance, that's the distance between total cost and total variable cost. Now I'm going to take the quantity axis, the horizontal axis, I'm going to drag that straight down. And now on the vertical axis, I'm going to put unit cost or cost per unit. Different than total cost, of course. So cost per unit. And I'm going to draw an average cost curve. Looks something like that. The average variable cost curve, and then marginal cost curve. And I will discuss the shape of these curves as well and what makes them kind of curvy shapes. First, I'm going to talk about average cost. If I pick a quantity and I look at the total cost for that quantity, average cost is equal to total cost divided by the quantity at that point in time. Now I take that quantity, I drag it straight down, so the quantity in this graph is the same as above, and then I plot average cost, which is total cost divided by quantity. It's that point right there. Now if I plot all those points, the cost curve drops, and then the cost curve actually goes back up. This is due to diminishing marginal returns. It's probably more correct to say average total cost, or ATC. Your textbooks probably have ATC like that. Your professor probably uses that. Now I'm going to draw the marginal cost curve. For marginal cost, I take a quantity and a total cost. And what I want to know is how much total cost increases if I increase quantity. To do this, I take the second total cost minus the first total cost divided by the second quantity minus the first quantity. You probably recognize that this is the same as the rise over the run, which is equal to slope. In other words, I take the change in total cost divided by the change in quantity is equal to the marginal cost. That little triangle is change in, and it's Greek delta. This is also equal to the change in total variable cost divided by the change in quantity plus the change in total fixed cost divided by the change in quantity. But the change in fixed cost is actually 0. The slope or the change in total fixed cost is 0 regardless of the quantity. It's fixed. So really, the change in total cost is equal to the change in total variable cost. I'm going to draw these two curves back in, total cost and total variable cost. Now if I pick a point and I look at the slopes of these two lines, it turns out the slope of the total cost and the slope of the total variable cost are the same. Those two lines are parallel. The slopes of these two lines are parallel all along the curves. As you can see, those lines are all parallel. So marginal cost is equal to the change in total variable cost divided by the change in quantity as well. They're equivalent. Now I'm going to plot the marginal cost. So I put cost per unit on the vertical axis. If I plotted all the points, the marginal cost curve would look something like that. An important concept is where the inflection points are. We'll draw in the average total cost curve. And I'm going to talk about these two curves for a few minutes. They're an important concept. In this first gray area, marginal cost is less than average total cost. The blue line is below the green line. The slope of that curve is negative in the gray area, and average total cost is decreasing in that area as well. At the point where marginal cost is equal to average total cost, the slope is 0, just a flat line like that, and average total cost is constant. Now in this last gray area, marginal cost is greater than average total cost. The blue line is above the green line. The slope is positive, and average total cost is increasing. I'm going to put everything back now, like it belongs. Now I'm going to talk a little bit about why the curves have the shapes that they do. Draw everything back. The first part of the curve, the gray area here, we have economies of scale. Now, in the second part of the curve, we have diseconomies of scale. A less interesting curve, I'll draw it back in, is average variable cost. It's the last line I'll draw in right there, average variable cost. And average variable cost is just the total variable cost divided by the quantity at that point in time. And then I just plot those points. This is equal to average variable cost. I'll draw the quantity down, straight down. And it turns out that if I draw in the average fixed cost curve, I get average cost is equal to average variable cost plus average fixed cost. So the distance between these two curves is just average fixed cost. And you see the point there. So for industries with low fixed costs, or if fixed costs begin to fall, what begins to happen, you see, that if fixed costs are less and less, let me just reduce fixed costs like that. You see that all the cost curves come closer together, and the average cost curve and average variable cost curves become the same line, basically. So if fixed costs are really low, let me move it down just even more, the average cost and average variable cost become the same curve to begin with. That's why it's a less interesting line. Now if I compare the total variable cost curve and the total product curve, the total variable cost curve is a reflection of the total product curve. They're reflections of each other, I should say. This is what gives the curves their shape. Let me explain. Now if I look at this area, that's the same area there. And when I add labor, I'll put some labor in. I can add labor at some point in time, increase a lot of quantity, which is that quantity right there. I can increase a lot of quantity because of economies of scale without increasing cost much. That's why it flattens out. But at the top of the graph there, it's the same as this area over there on the total variable cost curve. And in this case, when I add the same amount of labor as I did before, I get a very small increase in quantity. That little teeny bit right there. And it turns out this little bit of quantity increase is kind of expensive, especially relative to what I got before. And this is due to diminishing marginal returns. Let me draw in the first quantity and cost for you so you can compare those two. So up next, I'm going to do the same type of deal, except I'm going to use